Friends, welcome to the class. Today we'll discuss some questions on triangles. The first question states S and T are points on the sides PR and QR of triangle PQR such that angle P equals to angle RTS. Prove that triangle RPQ is similar to triangle RTS. Let's draw the picture first. So given triangle PQR, in triangle PQR, 2 points S and T lie on the sides PR and QR respectively. And also it is given that angle P equals to angle RTS. Construction: S and T are joined. The dotted line shows this is the construction one. Now proof. In triangle RPQ and triangle RTS, we have angle RPQ equal to RTS, which is already given. Angle PRQ equals to angle TRS because the R is the common angle. So this implies triangle RPQ is similar to triangle RTS by angle-angle similarity. Hence proved. Next question. In triangle ABC, DE parallel to BC, AD equals to 7x minus 4 cm, AE equals to 5x minus 2 cm, DB equals to 3x plus 4 cm, and EC equals to 3x cm. Find the value of x. Let's draw the picture first. So it is given that DE parallel to BC. So since D is parallel to BC, we have AD by BD equals to AE by CE, because since D is parallel to BC, we can say triangle ADE is similar to triangle ABC. So we can write AD by BD equals to AE by CE. So by putting the values of AD and BD, we have 7x minus 4 by 3x plus 4 equals to 5x minus 2 by 3x. Or doing cross multiplication, we have 3x into 7x minus 4 equals to 3x plus 4 whole into 5x minus 2, or this implies 21x square minus 12x equals to 15x square plus 14x minus 8, or this implies 6x square minus 26x plus 8 equals to 0, or on dividing by 2 on both the sides we have 3x square minus 13x plus 4 equals to 0, or doing middle term factorization we get 3x plus 1 whole into x plus minus 4 equals to 0. That means x equals to either 1 by 3 or 4. But x equals to 1 by 3 is not possible, as 7x minus 4, 5x minus 2 will give negative value. Hence, the value of x is 4 is the answer. In the given picture, angle PST equals to angle PTS and triangle NSQ is congruent to triangle MTR. Prove that triangle PTS is similar to triangle PRQ. Let's draw the picture first. So it is given angle PST equals to angle PTS and triangle NSQ is congruent to triangle MTR. Proof. Since triangle NSQ is congruent to triangle MTR, we have SQ equals to TR. This is first equation. Also, given that angle PST equals to angle PTS, this implies PT equals to PS because set opposite to the equal angles. Now, from equation 1 and equation 2, we have PS by SQ equals to PT by TR, or ST parallel to QR by converse of basic proportionality theorem. So angle PST equals to angle PQR and angle PTS equals to angle PRQ, because it becomes the corresponding angles. When ST parallel to QR, we have angle PST and PQR are the corresponding angles. Likewise, angle PTS and PRQ are also the corresponding angles. Hence, they are equal. Now, in triangle PTS and triangle PRQ, angle P is common. Angle PST equals to angle PQR and angle PTS equals to angle PRQ. So this implies triangle PTS is similar to triangle PRQ. Hence proved. In the given picture, two chords AB and CD of circles intersect each other at a point P when it produced outside the circle. Prove that first bit triangle PAC is similar to triangle PDB. Second bit PA into PB equals to PC into PD. Let's draw the picture. So given that AB and CD are the two chords of the circle, construction AP and CP are drawn. This AP and CP are the construction part that has been drawn. Proof. We know in a cyclic quadrilateral, the exterior angle is equal to the interior opposite angles. That means angle PAC equals to angle PDB, that this is first equation, and angle PCA equals to angle PBD, that this is second equation. For a cyclic quadrilateral, if all the four vertices of a quadrilateral touches the edges of the touches the circle, then we can say that this is a cyclic quadrilateral. And in case of a cyclic quadrilateral, the exterior angles here, angle C, PAC, PCA is the exterior angle. This angle is equal to angle B, and angle A, PAC, this angle is equal to angle D. So from equation 1 and 2, we have triangle PAC is similar to triangle PDB. Since this angle A equals to angle D and angle C equals to angle B, we can say angle PAC is similar to the angle PBD. So the first equation is proved, first bit is proved. Now come to the second bit. Since we have angle P, triangle PAC is similar to triangle PBD, we have PA by PD equals to PC by PB, or this implies PA into PB equals to PC into PD, hence proved. In the given picture, angle AEF equals to angle AFE, and E is the midpoint of CA. Prove that BD by CD equals to BF by CE. Let's draw the picture. Now given that angle AEF equals to angle AFE and E is the midpoint of CA. Construction CG is drawn parallel to DF. Proof. Given that angle AEF equals to angle AFE and E is the midpoint of CA. So we have CE equals to AE, or this is equals to AC by 2. This is first equation. In triangle BDF, we have CG parallel to DF. So we can write BD by CD equals to BF by GF. This is second bit. Now in triangle AEF, angle AEF equals to angle AFE, it is given. This implies AF equals to AE because side opposite to the equal angles. Or we can say AF equals to AE equals to CE, because from equation 1 we got CE equals to AE. So let this be equation 3. Now in triangle ACG is the midpoint of AC and EF parallel to CG, or this implies FG equals to AF. Let this is equation 4. So from equation 2, 3 and 4 we have BD by CD equals to BF by CE, as FG equals to AF equals to CE, hence proved. D is midpoint of side BC of triangle ABC. AD is bisected at point E and BE produced cuts AC at point X. Prove that BE is to EX equals to 3 is to 1. Let's draw the picture first. Given D is the midpoint of side BC, AD is bisected at point E and BE is produced cuts AC at the point X. Construction dy is drawn such that dy is parallel to bx. Proof. In triangle BCX, we have dy parallel to bx, or this implies triangle BCY is similar to triangle DCY. Sorry, triangle BCX is similar to triangle DCY. Or we can write bx by dy equals to bc by dy. Now bx by dy equals to 2 because d is the midpoint of bc. So we can write bx equals to 2 dy. Let this is first equation. Similarly, we have triangle AEX is similar to triangle ADY because already we have drawn dy is parallel to EX. So we can say triangle AEX is similar to triangle ADY. Or we can write AD by AE equals to dy by EX, or this implies dy by EX equals to 2 because E is the midpoint of AD. Or this implies dy equals to 2EX, twice of EX. Let this is second equation. So from equation 1 and 2 we have Bx equals to 4EX because Bx equals to 2 dy and dy equal to 2 times of Ex. So this implies Bx is 2 into 2 times of Ex, which is 4Ex. Or we have Bx by Ex equals to 4. Now Bx by Ex minus 1 equals to 4 minus 1, which is equals to 3. Or taking Ex as LCM in left hand side, Bx minus Ex by Ex equal to 3 by 1. Or we have Be by Ex equals to 3 is to 1 because Bx minus Ex is Be. Hence proved. In triangle ABC, the perpendicular from A intersect BC at point D such that BD equal to 3CD. Prove that twice of AB square equal to twice of AC square plus BC square. Let's draw the picture. Given that BD equals to 3CD and AD perpendicular to BC. Now BC equals to BD plus CD. So we can write BC equals to 3CD plus CD, which is equals to 4CD, or CD equals to BC by 4. So BD equals to 3 by 4 of BC. Now in triangle ABD, using Pythagoras theorem, we have AB square equals to BD square plus AD square. Let this is first equation. In triangle ADC, using Pythagoras theorem, we have AC square equals to CD square plus CD square. Let this is second equation. Now subtracting equation 2 from equation 1, we have AB square minus AC square equals to BD square minus CD square. Or this implies AB square minus AC square is 3 by 4 BC whole square minus 1 by 4 whole square BC whole square. Or this implies it is AB square minus AC square is 8 by 16 BC square, which is nothing but 1 by 2 BC square. Or taking 2, multiplying 2 on the left hand side, it is 2 twice of AB square minus twice of AC square equals to BC square. Or this implies twice of AB square equal to twice of AC square plus BC square. Hence proved. In the given picture, PQ parallel to BA and PR parallel to CA. If BD equals to 12 cm, find BD into CD. Let's draw the picture. So given that PQ parallel to BA, PR parallel to CA and PD equals to 12 cm. So we have PR parallel to CQ and PQ parallel to BR. Now in triangle RDP, we have DC by DP equal to DQ by DR as PR parallel to CQ. Let this is first equation. And in triangle RDB, we have DP by DB equals to DQ by DR as PQ parallel to BR. Let this is second equation. Now from equation 1 and 2 we have DC by DP equal to DP by DB, or this implies DC into DB equal to DP square, which is equals to, or you can write it as BD into CD equals to 12 whole square, which is 144 centimeter square. Is the answer. In the given picture, OB is perpendicular bisector of the line segment DE, FA perpendicular to OB, and FE intersect OB at point C. Prove that 1 by OA plus 1 by OB equals to 2 by OC. Let's draw the picture. So given that OB is perpendicular bisector of the line segment DE and FA perpendicular to OB and FE intersect OB at point C. Proof. In triangle FAC and triangle EBC, we have angle FAC equals to angle EBC because both are 90 degree, both are perpendicular. Angle FCA equals to angle ECB because these are the opposite angles. FCA and angle ECB, these two are the opposite angles. So we have triangle FCA, FAC is similar to triangle EBC by angle-angle similarity criterion. Or we can write FA by EB equal to AC by BC, or FA by DB equal to AC by BC, because B is the midpoint of DE. So EB in the place of EB we can write DB. This is first equation. Similarly, we have triangle AOF is similar to triangle BOD. Triangle AOF and triangle BOD. Angle A is common for both the angles, and angle FAO and angle DBO are 90 degree. That means two angles are same. So by angle-angle similarity criteria, these two triangles are similar. Or you can write OA by OB equals to FA by DB. Again, this is second equation. So from equation 1 and 2 we have OA by OB equal to AC by BC. Or this implies OA by OB equals to OC minus OA by OB minus OC. Now doing the cross multiplication, OA into OB minus OC equals to OB into OC minus OA, or you can write OA into OB minus OA into OC equals to OB into OC minus OA into OB. Now taking OA into OB to one side, we have OB into OC plus OC into OA into OC equals to twice of OA into OB. Or dividing on both the sides by OA into OB into OC, we get 1 by OA plus 1 by OB equals to 2 by OC. Hence proved. In an equilateral triangle ABC, D is a point on side BC such that BD equals to 1 by 3 BC. Prove that 9 AD square equals to 7 AB square. Let's draw the picture. Given triangle ABC is an equilateral triangle, D is a point on BC such that BD equals to 1 by 3 BC. Construction AE is drawn on BC such that AE perpendicular to BC. Proof. Since triangle ABC is an equilateral triangle, we have AB equals to BC equals to CA. Let this equals to A. So BD equals to A by 3 or CD equal to BC by minus BD, which is nothing but A minus A by 3, which is equals to 2A by 3. Since AE is perpendicular to BC, we have B equal to AC equals to A by 2, because in an equilateral triangle perpendicular to the side bisect the side. Now DE equal to BE minus BD, or D equals to A by 2 minus A by 3, which is equals to A by 6. Now in triangle AED, using Pythagoras theorem, we get AD square equals to AE square plus DE square. Let this is first equation. In triangle AEB, using Pythagoras theorem, we get AE square equals to AB square minus BE square. Let this is second equation. Now putting the value of equation 2 in equation 1, we get AD square equals to AB square minus BE square plus DE square. Or in terms of A, we can write it as it is A square minus A by 2 whole square plus A by 6 whole square, which is nothing but 7 by 9A square. Or this implies AD square equal to 7 by 9 AB square, or 9 AD square equal to 7 AB square. Hence proved. Friends, here is a few questions. Many of the questions have already appeared in earlier CBSE board exams. So these questions will be helpful from your exam point of view. But practice more and more such questions. And in case you come across any difficult question, do share your question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your questions. So this was for today's class. Thank you.